Hey guys, so today I'm going to be talking about the oxidation of alcohols. So there's two very important keys to remember when we're working with this mechanism. One is that we must always have alpha hydrogens, and the second is that when oxidizing, the alpha carbon loses one bond to hydrogen and gains one bond to oxygen. So let's start by looking at a primary alcohol. So here we can see that this carbon is attached to our OH, which makes that the alpha carbon, and we do have two alpha hydrogens here. So when oxidizing, this carbon will gain an extra bond here to oxygen. This group will still be attached, and so will this hydrogen. So this gives us an aldehyde, as you can see there. When you're going from a primary alcohol, you're always going to first get an aldehyde. We can see by our oxidation states of our carbons that this is at a -1 oxidation state, while this alpha carbon turned into a +1, as we can see that oxidized. Usually it's very difficult to isolate this aldehyde, and oxidation will usually continue. So then we will get this product, which, as you can see, is a carboxylic acid. Again, we can look at the oxidation state of our alpha carbon, which is here, and we can see that it's a +3 charge now, which means that it got oxidized again. This type of reaction would occur when we're using Na2Cr2O7, H2SO4, and water, and we know this as the Jones reagent. However, if you wanted to isolate this aldehyde right here, you could use something that's not as strong, such as pyridinium chlorochromate, which we also know as PCC, which is much easier to pronounce. So let's do an example here. If we start with ethanol and we use PCC to react, we will end up with this as the product. A double bond to oxygen. So moving on, we can look at secondary alcohols. Excuse me. So as you can see, again, we have an alpha carbon and an alpha hydrogen. So in reacting, we would get a double bond here to this oxygen. This group would still be attached, and this group, and then the hydrogen would disappear. So with this, you can see that this is a ketone. When reacting with secondary alcohols, the only product you can get is a ketone. So if we show an example with cyclohexanol reacted with PCC, the product would be double bond to the oxygen, just like that. Now, if we move on to tertiary alcohols, you can see that we have our alpha carbon here. However, it doesn't have any bonds to any hydrogens. Because of the first rule I taught you, that we must have an alpha hydrogen for the mechanism to occur, you cannot do this mechanism on a tertiary alcohol. So you would, in the end, get no reaction.